the World Health Organization has officially called it COVID-X.
COVID rising to the highest point since mid-February.
COVID-X by Matt Paquea and Rio. COVID-X, the most infectious disease in history. COVID-X is expected to continue to infect without stopping until the whole human population is infected. A change in a solution is needed. A simulated graph of the people infected over time is on the next slide. A definite integral for a period of 5 months is provided. Here is the graph that represents the rate of the spread of the disease, which is 2 to the power of x plus 3 minus 8. Now, in order to estimate and determine the total number of people infected with COVID-X over the course of 5 months, we would need to take the Riemann sum for an estimate and the definite integral for an accurate determination. So you can see that we found the total number of people infected by a definite integral, but I'll get back to that and approach the approximations using Riemann sums first. We approximated the number of people infected with 5 subintervals, which made it pretty simple as the points were simplistic whole numbers. The approximations from the left, right, and trapezoid Riemann sums turn out to be 208, 456, and 332 million people, respectively. And the left Riemann sum only appears to have 4 simple intervals because the first point is 0, 0. Now, for our precise approximation, we took the integral of the function bounded from 0 to 5, which represents the initial month to the 5th month. By using antiderivative rules and then the fundamental theorem of calculus, we found the accurate approximation to be 318 million people infected over the course of 5 months. Obviously, this is a large number of people, so we asked the question, how can we slow down COVID-X?
Alright, due to the infectiousness of COVID-X, we know we need vaccines. So here, we have a graph, and we're going to find the rate at which the rate of the spread increases or decreases at both t equals 25 days and t equals 150 days. The red line is the predicted spread over 50 days, and the blue line is predicted spread after 50 days if we find a vaccine. So f of x is defined by 1 over 120 times x minus 12.87 cubed plus 18 from 0 to 50, and then negative 1 over 1,250 x minus 50 squared plus 444.573 when x is greater than 50. So our solution, f prime comes out to be 1 over 40 times x minus 12.87 squared from 0 to 50, and negative x minus 50 over 625 when x is greater than 50. When we plug in 25 to f prime of x, we get 3.678 infected people per day per day. When we plug in 150 to f prime, we get negative 0.16 infected people per day per day. So the rate of spread for COVID-X is increasing by 3.678 people per day squared after 25 days since the outbreak, and this is without vaccines. But after 100 days with the vaccine being implemented, the rate of the spread is decreasing by 0.16 people per day squared. This means vaccinations are a necessary solution. All right, so should we provide incentives for vaccinations? The total amount of people infected by COVID-X are modeled by the equation R equals P minus 9 over 10V, where P equals total population, R equals total infected, and V equals total vaccinated. If the population increases by about 227,000 people per day and the total vaccinated increases by about 485,000 shots administered per day, should we provide incentives for more vaccinations? So here we want to use related rates. So dr dt equals dp dt minus 9 over 10 dv dt. So dr dt equals 227,000 minus 9 over 10, 485,000. And these are known values that we got in the previous slide. And then you solve and you get dr dt equals negative 209,500 people per day. So basically, the rate of infected people is decreasing by 209,500 people per day. And this is a great step forward, but I think we should add more incentives just because we can always decrease the spread even more.
Quarantine tents. People who have contracted the virus must be quarantined in large tents due to the lack of housing for infected persons. The volume in cubic meters of each tent can be found using the region bounded by y equals 1/2 x plus 3, the y-axis, the x-axis, x equals 5, revolved around x equals 5. If 25 people can fit in a volume of 100 cubic meters, how many tents are needed to accommodate for 500,000 people? So to find this, we will need to split up the volume of the tent into sections. So the volume of the cylinder on the bottom and the volume of the cone on top. The volume of the cylinder is given by the integral from 0 to 3 of pi times 0 minus 5 squared dy, which would result in 75 pi cubic meters. The area of the cone on top is given by the integral from 3 to 5.5 of pi times 2y minus 6 minus 5 all squared times dy, which would result in 125 pi over 6 cubic meters. And adding those two gives us the full volume of the whole tent, which is 75 pi plus 125 pi over 6, which would equal 575 pi over 6 cubic meters. And to find the number of tents needed, we would take this total volume per tent and multiply it by 25 people over 100 cubic meters, and that would give us about 75 people per tent. To find the number of tents we need, we would divide 500,000 people by 75 people per tent, which would result in 6,667 tents. So what are our solutions to the problem of COVID-X? Celebrity endorsements of vaccines. Free and easy access to these said vaccines. Ads, whether that be game ads, product ads, or even social media ads. Quarantine tents, where we put the quarantine people so that the disease does not spread further. And yeah, our works cited, and thank you for listening to our presentation on COVID-X and our solutions to the problem.